Okay, so this is the third video of the 1.4, the periodic table. In this video, we will be looking at the second box in this science understanding, the position of an element in the periodic, element in the periodic table is related to its metallic or non-metallic character. We'll be identifying the position of an atom in the periodic table given its electron configuration. And we will be also identifying the S, P, D, and F blocks of the periodic table, which kind of we have done, but yeah, we'll look at this in this video. Okay, the slide that we'll be looking at is slide 25. Okay, now let's look at the definition of metallic and non-metallic nature to start with. So it is the tendency of atoms to form cations and anions. Another way of saying is what element would want to lose electron or gain electrons. And if you break it down to how many electrons they want to gain or lose, yes, you can look at what sort of ion they would form as well, which is going to be extensively covered in topic 2. We are still in topic 1, and this is the last one. All right, metallic character. Now, metals have lower number of valence electrons, 1, 2, 3, yeah, electrons. These electrons are transferred to another atom during a chemical reaction to form a bond or to make something new. If electron transfers occurred, then that's considered as reaction as well. It's not a reaction if no electron transfer occurred. That's another way of saying too. All right. As a consequence of moving, metals losing electrons, yeah, cations are formed. They are positively charged ions, and the tendency of atoms to form cations is called the metallic character. So metals want to make cations. Okay. So sodium is there as an example, and sodium will become sodium plus, sodium 1 plus. You don't show 1, yeah, because you just don't put 1 in front of any variable. Okay, continuing on with metallic character, metals become what? It's going to be more reactive. We are talking about reactivity here as you move down a group. Why? More shells are added as you go down the group, therefore, and due to more distances from a nucleus, less attraction outer shell electrons will have. Therefore, a lower ionization energy, that is, a less energy is required to remove 1 electron. That means the elements in a group, lower down in the group, they have a lot more reactivity. Metals become more or less reactive as you go across a period. Well, if you remember, metals become less and less reactive as you move across a period. Why? Affinity towards valence electrons increase due to more protons being present. Yeah. So lithium, beryllium to sodium, magnesium to aluminum, you would observe that protons increasing from 11, 12 to 13. More protons there are, more pull the atom or nucleus will have. So if you go across, affinity towards electron will increase, therefore a higher ionization energy is required for you to remove electron out of it. Okay, let's look at non-metals. So they have high number of valence electrons, 5, 6, 7, which is close to the maximum number of electrons which a shell can hold. Electrons are added to a valence shell from another atom during chemical reaction. So if there was a sodium atom conveniently next to chlorine atom, they want to readily react by transferring electron to form ions. As a consequence of gaining electron, anions are formed. So negatively charged ions, they are called anions. the tendency of atoms to form anion is called non-metallic character. So chlorine is again there as an example. Okay, so non-metals become, so if you go down the group, what's going to happen to its reactivity? It's going to go, well, it's going to decrease. It's going to decrease. And what are the reasons? Hopefully you can sort of rewrite what you were saying, what we were saying for metals before, but opposite. So if you're going down the group, non-metals will be less reactive because number of shells are increasing, therefore there are more distance added from the nucleus to the outermost shell. Now outermost shell is where the electron will be accepted to make anion. If the distance is further, then the affinity that the nucleus will have to outer shell electron is much lower. Therefore, as you go down a group, non-metals will have less of the reactivity. How about going across a period for non-metals? Well, what you have to make note of is that group 18, noble gases are ignored. So let's look at from, say, boron to fluorine. There are 5 non-metals there. Sorry, boron is technically a metalloid, but say carbon to fluorine. What's going to happen? So 4, 5, 6, 7. That's how the number of electrons are increasing, and protons are increasing. If the number of protons is increasing, there should be more and more pull towards the electron. So as you move across from left to right, carbon to fluorine, the reactivity should increase because there are more protons, which can pull more electrons, or electrons more strongly. Okay, so that's the reason. Noble gases, as I've been mentioning, rarely form compounds because they already have full number of electrons for each shell. What's this configuration called? I have already been mentioning octet configuration. All right, here's a summary for metallic and non-metallic character. So if you go to right, ionization energy would increase. Electron affinity will also increase because there are more number of proton. And non-metallic character will increase if you go to right as well as go up. Non-metallic character we are talking about. Okay? And metallic character, which is wanting to get rid of electrons, will go down if you go down a group, and it will go up if you go across a period. If you go towards left, metallic character will increase or go down. So non-metallic and metallic would be opposite of it. Electron affinity or ionization energy also go up. Atomic radius increases as you go down and decreases as you go to the right. Okay. Based on all this information, we can now do question 24 to 26. And I believe that's the end of this part. So make sure you spend some time on understanding the content of what we talked about. Hello, where am I? There, that's fine. So make sure you understand all the trend and make sure you can explain why those trends are observable. Okay? In chemistry, knowing is one thing, but being able to explain is another thing. It requires practice. I want you to write few lines that explains the observation. Then you can apply afterwards. Okay? So practice writing them in sentences. All right, that's it. That's the end of 1.4, and I believe this is the last one for topic 1. All right.